Hello students, in class 9 science chapter 3 atoms and molecules. In this video we will discuss about atomic mass, molecules of elements and molecules of compounds. First of all, what is atomic mass? Since determining the mass of an individual atom was a relatively difficult task. Why it was difficult? Because atoms are very small and to get an individual atom is again a difficult task. Clear? That's why relative atomic masses were determined using the laws of chemical combinations and the compounds formed. Relative atomic mass is related with the mass of an atom of carbon 12. That is, mass of an atom of carbon 12 is taken as a standard. It is expressed in AMU, atomic mass unit, and now it is written as U, that is unified mass. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. We can say 1 AMU is equal to 1/12 into mass of one atom of carbon 12. The relative atomic masses of all elements have been found with respect to an atom of carbon 12. Relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of one atom of carbon 12. In this definition, why this average word is there? Actually, we will take the average of mass of all the isotopes of a particular element. What are these isotopes? We will discuss later on in this chapter. Is it clear? We can say whatever the mass we determine for an atom of an element, this is relative. Why this is relative? Because this is related to the mass of an atom of carbon 12 and this is average, actually average of the mass of all the isotopes of that element. Okay, in this table you can see the atomic masses of few elements. Hydrogen is 1, carbon is 12, nitrogen is 14, oxygen is 16, sodium is 23, magnesium is 24, sulfur is 32, chlorine is 35.5 and calcium is 40. How do atoms exist? Atoms of most elements are not able to exist independently. Atoms form molecules and ions. Only atoms of the noble gases, that is helium, neon, argon, krypton, xenon, radon, are able to exist independently. Other atoms of other elements will combine and they form molecules or ions. Now, what is a molecule? A molecule is in general a group of two or more atoms that are chemically bonded together, that is tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of same element or atoms of different elements can join together to form molecules. In this way, we will get the two types of molecules. First one is molecules of elements. Atoms of same elements join together to form molecules of elements. For example, a molecule of oxygen consists of two atoms of oxygen and hence it is known as a diatomic molecule and represented as O2. If three atoms of oxygen unite into a molecule, then we get ozone and it is represented as O3. O3 is the formula of ozone. The number of atoms constituting a molecule is known as its atomicity. That is, how many atoms are present in a molecule. This is called its atomicity. We can say like argon. Its symbol is Ar. It has independent existence. Only one atom can exist. That's why this is monoatomic. Helium, this is again monoatomic. Actually, these are the examples of noble gases. Oxygen, O2, diatomic. Nitrogen, H2, diatomic. Hydrogen, H2, diatomic. Nitrogen, N2, diatomic. Chlorine, this is Cl2, this is diatomic. Phosphorus, P4. 4 atoms of phosphorus combine and form a one molecule of phosphorus. That's why this is tetraatomic. In case of molecule of sulfur, 8 atoms of sulfur are present, and that's why this is polyatomic. Is that clear? Or we can also say these molecules of elements are also considered as homoatomic molecules. That is, atoms of the same elements are present. But in case of metals and some other elements such as carbon, do not have a simple structure but consist of a very large and indefinite number of atoms bonded together. Clear? Now, molecules of compounds. Atoms of different elements joined together in definite proportions to form molecules of compounds. Now, in this way, we can say different atoms of different elements are present. That's why these are also known the heteroatomic molecules or molecules of compounds. Okay, see the example like water, H2O. In this case, elements are hydrogen and oxygen. And if you find out the ratio by mass of these elements, it will come 1:8. This ratio can be found out by using atomic mass. We already discussed atomic mass of hydrogen is 1. There are 2 atoms of hydrogen, that's why 2. And atomic mass of oxygen is 16, that is 2:16. Its simplest ratio will come 1:8. In the same way, ammonia, NH3, elements present, nitrogen and hydrogen, ratio by mass is 14:3. Carbon dioxide, CO2, elements are carbon and oxygen and mass ratio, it is 3:8. Clear? Then how can we find out the number of atoms? Number of atoms can we find out by visualizing the formula. Like in case of water, H2O, 2 atoms of hydrogen and 1 atom of oxygen. In ammonia, 1 atom of nitrogen and 3 atoms of hydrogen. But another way we can also find out the ratio by number of atoms for a water molecule can be found as follows. Like in water, 2 elements are present, hydrogen and oxygen. A ratio by mass, this is 1 and this is 8. And atomic mass is, we know, for hydrogen this is 1, for oxygen this is 16. Now if we take the ratio of this, that is mass ratio divided by atomic mass. Mass ratio divided by atomic mass. So we can say that is for hydrogen, mass ratio is 1, atomic mass is 1, its ratio will come 1. And for oxygen, mass ratio is 8. Why this is 8? Actually this is the 8 is coming from here. And atomic mass is 16, its ratio is 1/2. If we take the simplest ratio of 1 and 1/2, it will come 2 and 1. It indicates that water contains 2 atoms of hydrogen and 1 atom of oxygen. Clear, students? Thank you.